talking about the entity relationship model. All right. Okay, so the recording has started. Sorry, I was having some problems moving my mouse there. Share the screen. Okay, so we are about to speak. We're speaking on the entity relationship model. The entity relationship model, as we identified, is a database model. Okay, it models how we store data, and it's based on the notation of real-world entities and the relationships among them. So you are actually capturing how, in a system, something that you want to keep information about, you want to capture data on those entities, and then you want to also capture data about how they relate to other elements of the system. Okay, so we can map real world scenarios onto entity relationship data models. Okay, we have three parts essentially to an entity relationship model. We have attributes, sorry, we have entities. Each entity has attributes, and each entities also have their relationships among them. So those are the three parts that we capture about the system, anything that we want to record, and anything that we want to record, and we display this. Now, the entity relationship model, you have to keep in mind that it is a blueprint. It is not the actual data. It is the map of how the data is going to be stored. Okay? And there are certain things that we need to know about the entity relationship model. So this is the ER model. This is how one of them they would look. And these are the parts that we will use. And I will show you a different notation as well. Okay? So we have the entity relationship model, and it's represented like this. And what we will be doing, the attributes will be stored in the ovals. And I will go through as well different types of attributes with you. But for now, attributes are if we have to define it, we'll say attributes are the characteristics of entities, the actual data items that we wish to store about an entity. So if, say, for instance, we had to capture information about a student, our entity itself is a student. Okay, so if we have an entity and the entity is student, what do we want to know about students? Anybody could tell me in a school system, if I have to store data about a student, what would I need to know? Some basic things I need to know about the student.
The name.
The name of the student, the date of birth of the student, yes.
Some maybe what form they would be going into, or their age
Right.
itself.
Right. So I like the form class, yes. Okay, so let's pause there. We have a good idea. We have some attributes of students. And the attributes of our students, as we have identified, are things like their name, right? Their date of birth, and their form class. And their name could further, right? So the sex as well, yes. And their name could be further broken down into like first name, and last name and other names. Okay, so we have this basic information about students. And let's say, for instance, in a schooling system, another entity that we want to capture data about might be something like let's say a subject. What are the attributes for a subject? A subject might have a name as well, right? A subject might have a description, and a subject might have some sort of prerequisite to something. So, but I don't want to make the example too complex. This is a really basic example. So if I am in my system, I simply want to know which student does which subjects, then off the bat, I can say that there is a relationship between the entity student with the entity subject. Okay? And if I want to represent this in my database, there are certain things that might have to be common to both to actually allow me to know that there is a relationship. All right? But let's just go back to defining the ER model itself. So we have an entity and an entity relationship model is a real world being. And there are some properties called attributes. And I want to extend on this, right? An entity does not have to be something that is tangible. An entity is something that can exist in the real world. So an entity could be something that is tangible, like a student, right? An entity could be something that is intangible, like an event or an occurrence or a happening, something that happened, something that took place, and you want to store information. So let's say, for instance, in a banking system, you are the customer and you are tangible as the customer, and you have an account, and there's a record of your account in the bank, and you do something like an account is something that's not exactly tangible. You can't really touch an account, but we're storing information about your account. And then you do something with your account, you make a withdrawal on your account. That's an event or that's an occurrence. That's another entity. And that withdrawal takes place on your account. Okay? So there's a relationship between you are the owner of your account, you own your account, and you also perform an action or an activity on your account, and that action or that activity is a withdrawal. And we have to record information about that action or that activity. Everybody understand where I'm coming from so far?
Yeah, sure.
Okay, I'm
Yes,
gonna
sir.
call a couple names because I just want to hear some voices. Clay, you with me?
Yes, sir.
All right, Jasmine.
Yes, sir.
All right, all right. Let me hear Chanel. Chanel, you with me?
Yes, sir.
All right. Last person, Iran.
Yes, sir, I'm good.
All right. Good. So we have an understanding of what an entity is. An entity is essentially anything that occurs within the real world that we want to store some information on. And then we have a relationship, and we by discussing just now the ways that the entities actually and I can say no other word but are related to each other, we've essentially defined the relationship. It's the logical association among the entities. So your relationships are mapped with entities in various ways. Okay? And the way that a relationship can happen in databases, because don't go and tell anybody that Mr. Valdez say that you should have a one-to-many relationship or anything so. And I know that some of you all roll in your eyes because every time your teacher talk about databases, that joke gets done, right? And worse yet, any kind of many-to-many relationship. But hey, if that's how you organize your life, we're not here to talk about that, right? We have different types of relationships in databases. So we have a one-to-one relationship, a one-to-many relationship, a many-to-one relationship, and a many-to-many relationship. And we're going to take a look at some of these relationships in a little bit. Okay? So they are different for entities interacting with each other, and cardinality is a really important word. Maybe I should put that in a better color than blue. I should put it in yellow. So we have cardinalities here, and cardinalities are a very important concept in databases. Okay? Your cardinality in a database, and maybe I'm going to, just for us to be able to discuss cardinalities, stick a page inside of here. Okay, so we have cardinalities. And we know that we have cardinalities indicate how many how many instances of an entity can participate in the relationship. Okay, a cardinality indicates how many instances of an entity can participate in the relationship. And let me put that here. Right? How many instances of an entity can participate in the relationship? Okay? And so for a relationship, for our cardinalities, we might have a one-to-one relationship. And an example of a relationship in a system, and these systems, these are discrete examples, eh? This is not all the same system. But say, for instance, I have an entity, right, called citizen. And I have another entity, and I'm going to be using a slightly different system. I'm not going to draw the triangle, okay? But I'm going to put one-to-many here, just for this example, and then later on I will show you a different way of representing what we are going through now. Okay, and somebody could have told me that I misspelled the word many. Citizen, and each citizen has a passport. This here is a one-to-one relationship. Okay, you can't have, in this system that we've modeled, you cannot, as a citizen of this country, have more than one passport. Does this make sense? This models how many instances of one entity happen with another entity. And I will let you know that one-to-one relationships are pretty rare at this level to have to represent. When you get into databases, at a higher level, there are certain times that you have to represent a one-to-one relationship. But a lot of times at a very simple level, a one-to-one relationship might beg the question as to whether or not what is in the second relation, if it can't just be expressed in the other one. Okay, but we're going here to understand a citizen, one citizen should have one passport. And maybe we need to represent citizen as separate from passport in this system. Okay? We have one-to-many relationships. And an example of a one-to-many relationships is maybe we have a system. Oops, sorry. This is, and I said I was going to draw it differently, and I drew it the way that I haven't taught you all as yet. So I apologize for that. So for now, we're putting one here and one here. All right. So as citizen, we always annotate the name of the relationship on the line, or you can put it into the diamond if you prefer. All right, but it's fine to just annotate the line. A one-to-many relationship might be something like owner and vehicle. So, and we read it like this: an owner can have, right? An owner has many vehicles, but a vehicle can only have one owner. So when you're reading this, you always read it from left to right, or you read it from top to bottom. But when you are reading back, like say from this side, for just your understanding purposes, you can change what is here. You can talk in a manner like if what is here has changed. So you can say a vehicle, right? Or in this case, has, I guess, would work as well. Or you could say is owned by a single owner. Or a vehicle has one owner. An owner, right, has multiple vehicles. The owner could have one vehicle, or the owner could have many vehicles. So the cardinality essentially dictates the maximum amount of instances there can be in a relationship. You can have more than one. Okay? And the many to one is just when it's flipped on the other side. So the many to one, it's the same thing if you put vehicle and owner on the next side. You'll just read it as a vehicle has one owner, right? So the many to one is the same, essentially, right? A pet right? A pet can have one owner, but an owner, right, can have many pets, right? So a pet belongs to one owner, but an owner has many pets. And then we can have something like a many-to-many relationship. A many-to-many relationship. And this is a relationship. This is a relationship that both instances there are multiple occurrences of the entity. So notice, however, that every time I've written the entity's name inside of here, I always use a singular noun. That holds true even for the many-to-many relationship. right? We don't say an owner has many vehicles. Vehicle is an instance of the entity. It just so happens that we have many of the vehicle, but we don't put vehicles here. So it's always singular inside of the it's always singular inside of the entity. So we have many to many, and a many to many relationship might be a relationship between a student and a course or a class. Let me just say course, right? And a student, right? Writes or attempts or attends. Let me put attends. Attends many courses. A course is done by many students. Ask your questions at this point. Ask your questions at this point. Does anybody have any issues at this up to this point?
So that's how we're supposed to write the relationship with the 1 and the M?
No, I will I'm doing this for this section. I will show you all the notation afterwards how I would. Josiah,
Okay.
I'm getting to what you asked about now, but I want to make sure that cardinality is understood before I move on to the next section. Josiah.
Okay, sir, thanks.
No problem. So,
So
mhm.
the cardinalities will be the relationships themselves, right? As the one to one, the one to many, the many to one, and the many to many.
I would not describe it as that. I would describe cardinality as a constraint of the relationship, not the relationship. The relationship is, you know, the how one entity interacts or refers to the other. But the cardinality is an aspect of the relationship. Because there is a second aspect of the relationship that I'm going to talk about right now as well. So any more questions on cardinalities? Anybody feels like they don't understand, they need a little go over on this? Or cardinality seems simple enough? Okay, so it says, good. All right. So as I mentioned just now, when I was talking to Joshua, right, Mr. Hazard himself, the cardinalities are one aspect of the relationship. There's a second aspect of the relationship called modality. Right? Modality, and sometimes you'll see this represented as participation. All right? So we have modality, and modality indicates if an entity must participate in a relationship with another entity. All right? So you could think of modality as, you know, where some of you all might watch some celebrity and you say, hey, that celebrity, she's my girlfriend or that's my boyfriend. All right? And you all invested in this relationship with the celebrity. And this celebrity don't know that you even exist. So on your side, you have full participation in that relationship. On the celebrity side, the celebrity has zero participation in the relationship. All right? So we have some reactions there. All right? Hey, it happens in life. Okay? It's one thing when it happens with Josiah, it's a one-sided relationship. All right. But in the event, in the case of database building, it's not a bad thing. In the case of our sad existences, it might be a little, it might be cause for intervention from friends and family. So, they might have to sit you down and be like, hey, this relationship you have with this celebrity is not healthy. You're worried about it. All right. So we have, if an entity must participate in a relationship with another entity, or if the relationship is optional. Okay. Modality is denoted by a 1 or a 0. So it's denoted by a 1 or a 0. And that means that this is the least amount. This is the least amount of instances of an entity that can participate in that relationship, right? Which indicates that this is the least amount of instances that can participate in this relationship. So we have that 1 or 0 modality, and that modality tells us, okay, on that side, is there any, what is the minimum amount of instances that can participate in this relationship? Okay. Just remind me at break time, I have a question to ask you all in the chat. Just before we go on break, right? Which will happen in about 10 minutes. So, all right. So we have modality. And modality now, if we take the relationship of citizen and no, I would prefer that vehicle or owner, right? If we have a relationship for vehicle and owner. So in the relationship that we had, which was the one-to-many relationship, we have that an owner has a vehicle. And let's say, for instance, we are running, and modality might be influenced by let's say, for instance, the business rules of an organization. Let's say we have a vehicle club, and this vehicle club, we want to keep track of who owns what vehicle and who also drives what vehicle. Understood? So we have an instance of who owns which vehicle and who drives which vehicle. And I'm going to put in the driving relationship just now, right? But we have owners. To be in this club, you must own a vehicle. What does that tell me about the modality of that relationship? Right? So if it is that in this instance, we to be in this club, this vehicle owners and drivers club, you must own a vehicle. Well, it tells me that the modality of this relationship is that an owner can have at least one and at most many vehicles. And a vehicle, in terms of an owner, a vehicle must have 1 and only one owner. Okay? So let's say, for instance, we have some information on drivers as well. So we have people who drive vehicles. A vehicle, anybody could think they could tell me what's the one-to-many relationship between vehicles and drivers? Right? Vehicle is operated by a driver. But should a vehicle must have a driver? And we say a driver is anybody who the owner gives permission to use their vehicle. If you're the owner and you like driving your vehicle and you don't like anybody else driving your vehicle, what's the modality here? Should I call a name? Or anybody want? Could you repeat? The person who talked just now.
So you asked the modality of the relationship between the vehicle and the drivers?
Yes.
Will it be a 1 to 0?
Okay, right. Let's just say the modality vehicle is operated by drivers. Okay, right? Yeah, we have an instance where a vehicle does not necessarily need to have a driver, but a vehicle can have many drivers if necessary. So if Ryan owns a vehicle, Ryan is an owner, and Ryan says, okay, I appoint Natalia and Aaron and Joshua as drivers of my vehicle. The relationship between Ryan's vehicle and drivers is a one to many. Okay, and this we just taking a look at that one instance. There are many drivers for that vehicle. But let's say David owns a vehicle, and David decides his vehicle is too precious to him to appoint anybody to drive. The only person who should drive David's vehicle is David. David has 0 drivers. So that's where we have this part here. David's vehicle in this database, it doesn't have any drivers associated with David's vehicle. Now, let's say, for instance, Jasmine has a vehicle as an owner, and Jasmine also thinks that Natalia should drive her vehicle. Then the relationship between drivers and vehicles should be what in terms of modality and cardinality? In terms of modality and cardinality, what should it be? It would be that a driver should be
one.
Yeah, right, 1, or how much is the maximum amount of vehicles that a driver could drive? A driver could drive many vehicles. Yes. So look at the logic here, right? We have owners, we have an owner. So our owner in this instance is Ryan. Let me put it in a different color so that this red all over the place, it kind of gets into us. So let's say Ryan owns the vehicle PAA 5555. All right, Ryan likes some old vehicle. And Ryan, so this is Ryan's vehicle here. And Ryan said that PAA 5555, we have some drivers. We have Natalia. We have Aaron. And Ryan said that PAA 5555, his little old putt-putt, could be driven by anybody. Okay? Then we have Varun. Varun owns a vehicle as well. Okay, Varun owns a vehicle as well. Let's say Varun owns PD, what we reach? PD what? PDJ? I don't know. 1, 2, 3, 4. And Varun does not think that anybody should drive his vehicle. What we have as our blueprint up here allows for this. And then let's say, for instance, that we have Kalika as a vehicle owner. And Kalika owns a vehicle PDN, right? 3131. And Kalika also thinks that Natalia drives well enough to drive her vehicle. This also is in keeping with what is going on in the system. Because Ryan owns this one vehicle, right? Ryan owns this one vehicle, and Ryan allows multiple people to drive it. So this vehicle can have 0 or more drivers. In this case, there are more. Varun owns this one vehicle, and Varun doesn't let anybody drive it. So that there's that 0 in play. A vehicle does not have to have a driver, right? Kalika owns this one vehicle, and Kalika allows for one person to drive it, which is fine because, you know, it could be one or more persons as a driver. Let's say, for instance, Ryan wins the lotto, and Ryan buys a nice new vehicle, okay, a PDZ, a PDZ, and I realize that we're already in E already, so I don't even know why I'm working with PD. And Ryan is stuck in his old ways, and Ryan does get used to not driving around his own vehicle, so Ryan still allows Aaron and Joshua to drive his vehicle. It says here that an owner can have multiple vehicles. So Ryan does now have PAA 5555 and PDZ 1111. And Ryan allows both of those vehicles to be driven by multiple persons. Varun, as I said, just to recap, Varun decides nobody drives his vehicle. That's fine. Kalika, she has one driver and she's the owner of her vehicle. So the modality indicates for the relationship, right? Remember that for the relationship, it denotes the least amount of persons that should participate in that relationship. So in the case of an owner and a vehicle, the least amount of persons is one person either way. We cannot have a vehicle in the system without an owner. We cannot have an owner in this club without a vehicle. So if you lost your car, you get kicked out of the club. However, the relationship between vehicle and drivers, we can say a vehicle doesn't have to have an additional driver. So there's a 1-to-0 relationship between vehicle and drivers. But a driver must drive at least one vehicle to be in our system. If you don't drive a vehicle that is registered with our club, then you do not have access to our club. And this example at the bottom here, this little rough sketch shows that. Are you with me?
Yes, sir.
Yes, sir.
So
Anybody
the
who
modality,
said no?
is one ... one thing. Is
The
that
modality is the first one here,
okay?
right? Is the modality. The second one is the cardinality in this example. Okay, so the cardinality is the second dot. And when we come back from break, I'll show you all an alternative way of representing this. Okay, but before we go on break, I just want to make sure that everybody understands what cardinality is and what modality is. Are there any questions before we go on to the break? No? All right. So everybody stay silent so that.
So,
Mhm.
say, yeah, man.
Yes, I hear you.
The owner can be considered like a driver as well. Like, yes, he owns the vehicle, but can't he be a driver for his own vehicle?
Yes, in this case, but why in terms of the rules of this system, why double things up? So an owner is defined as the person who is legally in possession of the vehicle. A driver in this case is defined as somebody who I have authorized to operate my vehicle. So again, these diagrams are created based on the rules of a business. There are ways to represent a driver being an owner, but those are beyond the scope of what CAPE CSEC needs. Trust me, you will have a lot of fun with representing things like, you call that inheritance, and you have like what you call optional or disjoint in terms of having inherent entities. But that's not within the scope of our learning, right? We just want to get used to representing entity relationship diagrams at a very basic level. So this is where we are. So right now it's better to separate owner and driver. Is that fine, Josiah?
Oh, yes, sir, thanks.
No problem. Anybody else
So-
has any more?
Yes, sir.
Joshua?
Express cardinality as a number.
Cardinality. Yes, cardinality can be expressed as a number. And again, that is outside of the scope of what they will ask in CompSci. I have never seen it asked, but you can limit the upper many. So let's say, for instance, our club, and this is just for illustration purposes, let's say, for instance, our club decided that the maximum amount of drivers is 4 persons. Right? It'll look like this. So what the database design is telling me is that a vehicle could have 0 and up to 4 drivers. But we don't really do that in CAPE level computer science. Is that okay, Azad?
I believe so. Yeah.
Okay. All right. So yes, it can be done, but it's not what we are looking at here. All right. So it's 10 o'clock. I want you all to take a little break. So soak in what we've learned. So I am going to pause the recording now.